Hello students, welcome back to our channel Diksha Karnataka. So as you know, we have already started a series where we are discussing the top 30 questions from all the important chapters. So in this video, we'll be discussing the top 30 questions from one of the organic chemistry chapter, that is alcohol, phenols and ether. It is a very high weightage topic and you can easily expect 3 to 5 questions from this topic. And I have also done videos for the other topics like kinetics, solutions, electrochemistry, coordination chemistry and DNF block elements. So the link of these videos will be there in our comment section. Please go and watch it. It will be very helpful for your KCET exam. Okay. So let us start with our first question of this chapter. First question is a better reagent to oxidize primary alcohol into aldehyde. So you know this is partial oxidation. Alcohols on strong oxidation will give you acids, but on primary we have primary alcohols. If we treat it with mild oxidizing agent, okay, we can end up with aldehydes. So this is a direct reagent based question. Correct answer for this question is PCC, or you can use PDC. Okay. Next, compound P and R in the following reaction are. So first let us write down the product and then we can see which type of isomers they are. So we have first CH3COH. Okay. Here we can treat it with CH3MgBr. Okay. Now this CH3MgBr is nothing but a Grignard reagent. So you can just denote like plus minus, here minus and plus. This one will attack here. We will get CH3COMgBr, and then here we have H, and then here we have CH3. Okay. Now when you given H3O plus, this one will be getting converted to alcohol, right? So I'll get this alcohol, 2-methyl, propane 2OL, then one concentrated H2SO4 with heat. This will do dehydration and I will get the product CH3CH double bond CH2, right? Now again you are adding B2H6 H2O2 in presence of OH minus. So this is hydroboration oxidation where OH is added according to anti-Markovnikov's rule. So what will happen here? We will get CH3 CH2 CH2OH. Okay. So now if you see the relation between the first one, that is your P, this compound, okay, and we have this compound, right? So what is the relation between these two? These two are your functional isomers. Okay. So the correct answer for this, these two are your position isomers, because OH is present here on the second carbon and here OH is present on the first carbon. So the correct answer for this question will be option A, that is position isomers. Okay. So let us go to the next question. The heating of phenyl methyl ether with HI produces an aromatic compound A, which on treatment with concentrated nitric acid gives B. A and B respectively are. So first let us draw phenyl methyl ether. Okay, this is phenyl methyl ether and it reacts with HI. So we know whenever such type of cleavage happens, the O group always remains with the benzene ring. So we will get this compound, one is phenol, okay, and another will be CH3I. Now when nitration is done for this one, okay, if you do nitration, we will get OH. Okay, this nitration, if it is a OH group which is a highly activating group, nitration takes place in all the 3 ortho, para and 2 ortho position and 1 para position. Okay, this compound is your picric acid. So we will get compound A is phenol and compound B is picric acid, right? So the correct answer for this question is option number D. Okay, next. Again we have one reaction NaOH. So first of all we know OH reacts with Na to give you O minus Na plus. Okay, this one is my A. Then this one reacts with CO2 to give you this compound. We have OH and then COOH. Okay, then when you do this one acylation, right, this is your acylation, we will get COOH and then OCO CH3, right? So this compound you should know the structure and its name. It is aspiring. Okay, the correct answer for this question is option number B. Next, an organic compound with molecular formula C7H8O. So listen, whenever we have number of carbons more than 6, okay, so it is more chance that this compound will be a benzene ring. Okay, possibilities are higher. So just think in that way. So C7H8O dissolves in NaOH and gives a characteristic color with FeCl3. On treatment with bromine, it gives a tribromo derivative, that is this compound. The compound is, okay. So first of all, you see 6 carbons are there, and we have, I can write like this. By seeing the options, we can see if what it gives you tribromo derivative, right? Now we know a phenol directs the bromine in this ortho position, and this para position, right? It will never direct to meta position. So that is why, what is these structures? Let us first see the options here. Option A is this one, okay? This is option A. Okay, then we have para cresol, OH, and then CH3. Then benzyl alcohol is there, CH2OH, and then we have orthocresol, right? So now, if the tribromo derivative is taking place, so there cannot be CH3 group in the para positions and ortho positions, okay? So in that case, you can eliminate these options. Now we are having metacresol and we have benzyl alcohol. So we know this benzyl alcohol will not react with FeCl3, so that also we can eliminate. So the correct answer for this question will be option E. Now when we are treating it with bromine, so what will happen? Bromine will be replaced in this position, ortho, para, and then we have another ortho position. Okay, we'll get this compound. So the correct answer for this question will be metacresol. Next, among the following products formed by the reaction of anisole with HI. Okay, so what is the structure of anisole? And we are treating it with HI. So we will get OH phenol group plus CH3I. Okay, so that is phenol plus iodomethane. So the correct answer for this question will be option C. So from ethers, you will be knowing questions from this part, the cleavage of ethers and the synthesis of ethers. Okay, these two topics are important. So practice more questions from here. Next, in Cole's reaction, the reacting substance are. So this is direct reaction based question, that is sodium phenate and carbon dioxide. Okay, so that answer for this question is option number C. So this is direct name reaction. So all the name reactions of this chapter, you have to just remember their reactants, reagents, any other conditions and the products. Okay. Next, which is most viscous? So viscosity depends on the strength of the intermolecular bonding. Okay, your intermolecular forces. So glycerol will have 3 OH group. We have this 3 OH group, because of which there is strong hydrogen bonding. So that is why it is more viscous. Hence the correct answer will be option number B. Next. Okay, a compound C7H8O is insoluble in NaHCO3 but dissolves in NaOH and gives a characteristic color with FeCl3. When treated with bromine water, A forms a compound B with the formula C7H5OBr3. So this is a very similar question that we have just discussed. It is, if you have this compound and CH3, right? So when you do bromination, we will get bromine on this 3 points, that is this ortho, this para position and this ortho position. So this ortho and para position should be empty, okay, it should not be blocked. So that is why the answer cannot be option C and option D, okay. And so that is why the correct answer for this question will be option B, right. So already the similar question we have discussed. Now coming to the next question, CH3CHO gives you CH3MgBr in presence of H3O plus, we get A, and then concentrated sulfuric acid we get B, and then we get C, right? Okay, so let us see the reaction here. CH3COH with CH3MgBr. So this one will give us CH3COH, CH, and then CH3. then concentrated H2SO4 will do dehydration, right? So we will get a removal of water molecule, we will get an alkene here. Okay, now after this, again this B2H6 will add OH following anti-Markovnikov's rule. So the CH3 CH2 CH2 OH will get, right? So the relation question is asking you the relation between this compound, okay, and this compound. So you can see OH is in the second position here and OH is in the first position here. So these are your positional isomers. So the correct answer for this question is option B. Next, steps involved in the conversion of propane 2OL to propane 1OL are in the order. Okay, so we can see here first is heating with PCl5 means that is a dehydrating agent, again we will get an alkene. So let us check the first option. If I have propane 2OL, okay, and you treat it with PCl5, so we will get propene. Okay, so first, sorry, this one will first convert, OH will be getting converted to, if we have PCl5, we will first, it will get converted to chlorine group, right? So we can write this one as PCl5, OH gets substituted with Cl. Next we have alcoholic KOH, so it will do elimination and we will get a propene or a double bond will form. Then acid catalyzed water will add OH following Markovnikov's rule. So OH will be attached to the carbon having less number of hydrogen, right? So this carbon is having only one hydrogen, so the OH part will be attached to this carbon and we will get the product CHOH and CH3, right? It is the same one which we have started. So propane 2OL and again the product is propane 2OL. But we want propane 2OL to propane 1OL. So this answer, this step is wrong. Now let us see the next one. If we have again propane 2OL, okay, and then treating with PCl5 will change OH to Cl, okay, and then we have heating with alcoholic KOH, so we will get this one. Now hydroboration oxidation, if you remember, it adds OH following anti-Markovnikov's rule. So OH will be attached to the carbon having less number of, OH will be attached to the carbon having more number of hydrogen. So if you compare this carbon and this carbon, here we have one hydrogen and here we have two hydrogens. So this one will be attached here. We will have CH2 and OH, right? So this is propane 2OL and this is propane 1OL. So the correct step will be option number B. Okay, next question. Which of the following on heating gives an ether as the major product? Okay, so in this we have two reactions, that is one is RX plus R-ONA. Okay, now when these two react we get R-OR. So in this one the condition is this RX, okay, it should be a primary one, right? So we can check the option here. Yes, this one is a primary one. Here this is also primary one. This is one tertiary. This one will not react, and this is also, this is not attached to sp3 carbon, right? So according to the condition we can say P and Q. So both P and Q, that is your option number C. Okay, so this condition comes from your Williamson ether synthesis, right? So very important reaction. In ethers we have generally two questions. One is cleavage of ethers, another is from Williamson ether synthesis. So please do more questions from this part. Okay, next is acids and their pK value. Here we have to know certain thing. If the acidic strength is high, if it is acidic strength is high, then pK value will be less. Okay, more the pK value, weaker is the acid. So we know picric acid is the strongest acid, so its pK value will be the least one. So we can say out of this, this is the least value, so D will be 2. So these options we can eliminate, these options we can eliminate. Okay, next one is your paranitrophenol is more acidic. So the next value, that is 7.1, should be for paranitrophenol. B should be 4. So this one is here and this one is different. So the correct answer for this question will be option A. Okay, next. Which of the following can be used to test the acidic nature of ethanol? So the acidic nature are treated with reactions with metals, okay? So we can treat it with sodium metal to test this. So correct answer will be option number D. Okay, next. Phenol can be distinguished from ethanol by the reagent. Okay, so here we have phenol. If you treat, okay, with bromine water, we get tribromo substitution, OH, Br, Br, and then Br, right? So this is a white color precipitate. So this reaction you have to remember. So it can be distinguished by treating with bromine water, whereas ethanol will not show the same reaction. Next, when the vapors of tertiary butyl alcohol are passed through heated copper at 573 Kelvin, the product formed is. So here we should know, if it is in primary alcohol, we get aldehydes. If it is a secondary alcohol, the product is ketones. If it is a tertiary alcohol, then we get alkenes as the product, right? So you can see this one ketone will not be there. This is aldehyde will also be not there. These two are there. We can check both A and C options. So first is butyl, tertiary butyl alcohols. This is the condition. Now when there is elimination, we get this product. Okay. So if you just name it 1, 2, 3. So 2-methyl propene, right? So we will get 2-methyl propene. So correct answer for this question will be option number C. Okay, now let us see the next question. What is the increasing order of acidic strength among the following? So here the concept that we have to remember is, if it is an electron withdrawing group, okay, then acidity will increase. And if we have electron donating group, then acidity will decrease. Okay, these two things we have to remember, and then we have to check all the options and which is electron withdrawing group and which is electron donating group. So coming to the first option, para-methoxyphenol. So we have this one is the first group. We have para-methoxy, right? OCH3 phenol. This is option 1. Then we have para-methyl phenol. So this one, para-methyl phenol. Then we have para-nitrophenol. So after writing the structure, we can just check. And one more thing we have to consider is plus R will have more effect than plus I. Similarly, minus R will have more effect than minus I. Okay. So now if you see, NO2 group is which one? Electron donating group through plus R. Sorry. We have NO2 group, which is your electron withdrawing group. So let us write down all the groups for here. NO2 is electron withdrawing group, minus R effect. OCH3 is electron donating group, plus R effect. CH3 is also electron donating group, and it is plus I effect. Okay. So now first of all, we'll check the electron withdrawing group will increase the acidity. So definitely this one, third one will have the highest acidic nature, right? So we can have only one option is there, that is option C will be correct, but we can check other options also. Now if you see this one, plus R is more dominant than plus I. Both of them will be they reduce the acidic nature, but plus R will reduce more. So 1 will be the least acidic, then 2, then 3. So the correct answer will be option number C. Okay. Such questions are very important where you have to arrange the acidic nature. Okay. Here questions are asked on the basis of your pK values, Ka values and acidic nature. So you have to remember pKa and Ka are inversely related. Okay. Next question. Okay. So we have the products for the following reaction. This is very important one. The preparation of phenol from cumene. Important reaction. So first of all, when we add this compound forms isopropyl benzene, this one. Then when you treat it with oxygen, oxygen gets attached here. And finally, the product that we get is phenol and CH3COCH3. Okay. So this method, this reaction is directly there in the preparation of phenols from cumene. Okay. So now if you see, the question is asking to identify, we have this X and Z. So X is your isopropyl benzene and Z is your acetone. So the correct answer for this question will be option number A. So direct reaction based questions are asked. So prepare all the reactions in this chapter, especially the methods of preparation. Okay, next which one of the following is true? Again, we have a question on acidic nature of the phenol. Very, very important. First is orthocresol. So let us do the structure. This is orthocresol. You should know the common names of the structures also, okay? Then we have phenol. And then we have orthonitrophenol. Again, we will do here, identify the electron donating group and electron withdrawing group. So nitro group is electron withdrawing group, right? So it will increase the acidity and it has minus R effect. In phenol, there is no substituent. Then CH3 is what? This is plus I effect. Okay, electron donating group. Okay, so now if we see, the most acidic will be the orthonitrophenol, and then least acidic will be orthocresol, and phenol will have no effect because it is not having any substituent here. So the correct answer for this question will be option number B. Next, which of the following cannot be used to oxidize primary alcohols to aldehydes? The primary alcohols, if you do strong oxidation, okay, they will get converted to acids, and if you do mild oxidation, they will be converted to aldehydes, okay, for primary alcohols. So you see CrO3 is a mild oxidizing agent, PCC mild oxidizing agent, KMnO4 is a very strong oxidizing agent, and it converts primary alcohols to carboxylic acids. So that will not be used or cannot be used to convert primary alcohols to aldehydes. So the correct answer for this question will be option number C. Okay, next. The products formed during the following reaction. Again, this is from your cleavage of ethers. 3-4 questions have come from this topic alone. So very important. We have tertiary butyl group, then O and then CH3, and this one is reacting with HI. So if you see, this carbocation will form, it is a tertiary carbocation. So carbocation will take the I minus. So we will get here CH3 and I. See, so if this part is a tertiary one, then it will be connected with HI part. Okay, the I of the HI will be connected to the tertiary carbocation. Or in case if this would have been a phenol group, something benzene ring, then the breakage will take place here. Okay, like we have done the previous question. So this one will form and this one will take your H. So we will get CH4. So which option? That is your option number we have with this compound here and not this one. So the correct answer will be your option number A. Okay, so cleavage has taken here, so we will get CH, this product. We can get here CH3OH. Okay, so option A will be the correct answer. Next, in the reaction ethanol, okay, we can see the first is it is giving you ethanol, so CH3 CH2OH. Then when you treat it with PCl5, what will happen? This will get converted to CH3 CH2Cl. Then in alcoholic KOH, there is alkene group. Okay. Then when you treat water, this is addition of water under acidic condition. So this generally follows Markovnikov's rule, but in case of symmetrical alkenes, there is no question of Markovnikov and anti-Markovnikov rule. Wherever you attach, the product will be same. So we can attach any one carbon with H and any one carbon with OH. So the correct answer for this question will be option number D. Next, again the compound which is most acidic. So again you have to check whether electron withdrawing groups are there or electron donating groups are there. So if you see here, first one, this is NO2 electron withdrawing group. It will increase the acidity, discussed so many times. This is electron donating group through plus I effect, right? This Cl, okay, Cl is also electron withdrawing group, but it has minus I effect. So as I told you, minus R is more dominant than minus I. So the correct answer for this question will be option number C. Next, the reaction which involves dichlorocarbene as an electrophile. So this is a very, very famous name reaction, that is your Reimer-Tiemann reaction. So you have to, no need to know the mechanism, but you should know one intermediate like this is involved in this reaction. Okay, that is your dichlorocarbene. Next, Ethanol is converted to ethoxyethane. So we have this one, ethanol, okay, is converted to ethoxyethane, concentrated H2SO4. So if you remember, here we have two temperature conditions. Okay, if you do the reaction at 413 Kelvin, then substitution takes place and we get ether. Okay, and if we increase the temperature to 443 Kelvin, the reaction elimination takes place and we get alkenes, right? So these two are important point. Temperature is very important factor here. So you see here 140 degrees Celsius is nothing but 413 Kelvin, right? So heating excess of ethanol with concentrated sulfuric acid at 140 degrees Celsius will give you the ether. So the correct answer for this question will be option number A. Now if you do 443 Kelvin, the product will be alkene based on the elimination reaction. Okay, next. Arrange the following compounds in the, again we have acidic strength. So let us draw the structures first. Meta-nitrophenol, we have OH and then NO2. Metacresol, so that is OH, CH3. Then we have only phenol and then we have metachlorophenol. Okay. Now let us see whether it is electron donating or withdrawing, and if it is donating plus R or plus I, if it is withdrawing minus R or minus I. So if you see NO2, okay, so NO2 is a electron withdrawing group and it has minus R effect. Now CH3 is a electron donating group and it has plus I effect. OH has no substituent, so we can ignore it. Now chlorine is an electron withdrawing group and it has minus I effect. Okay, so now all the withdrawing groups are more in acidic nature, right? So obviously option number 1 and option number 4 will come first. Out of 1 and 4, R is more, minus R is more dominant, so 1 will come first. So we can eliminate these two options, right? This one and this one. Now after 1, 4 has to come because it is also electron withdrawing group. So 3 is here, so we can eliminate this one. Correct answer will be option number D. So we'll get first 1, then 4, then this one is decreasing the acidity. This is neutral. So next will come your 3 and then will come 2. Okay. So very important, many questions are asked from acidic strength. Prepare this topic thoroughly. Next. Okay, again reaction based question. We have this structure. One aldehyde is given and you have reaction with Grignard reagent. So this Grignard reagent, you can take this side as plus, minus, here we have plus and here we have minus. This one attacks here. So you will get a structure like this, OMgBr, and here we have CH3, right? Now if it is done hydrolysis, this one will be getting converted to OH, CH3, and then here we have CH3. Next we have another CH3, okay, and here we have OH, okay. So now we will get, this one is the substituent, so just nomenclature 1, 2, 3 and 4. So we have 3 methyl butane 2-ON, right? The correct answer for this question is option number A. Okay. Next is your, okay, this question is little important one, reaction based. First we have OH. This part is your acylation. C6H5CO Cl in presence of any base, right? So this one will give you O. So this is acylation, we have OCO C6H5. Okay. Now nitration. Okay. Now see here, this group is an electron donating group. Okay. So nitration will take place either at ortho position or at para position. Based on the options, you can see that nitration has taken place in the para position. So the compound, so this nitration will take place here and this will be the product, right? So we have this one, then CO group, then this one and then nitro group. So the correct answer for this question will be option number A. Okay. So this one is little tricky question. So just practice some more reaction based questions from here. Next. Okay. Very important question, this one. 0.44 gram of a monohydric alcohol. Monohydric alcohol means the compound has only one OH group. When added with methyl magnesium iodide in ether liberates at STP 112 ml of methane. With PCC, the same alcohol forms a carbonyl compound that answers silver mirror test. Okay, so many data are given. See here. First of all, we have a monohydric alcohol. The formula is not given, but its mass taken is 0.44 gram. Okay, now this one is treated with methyl magnesium iodide. Okay, now when this one is treated with this one of the byproduct is methane, which is around 112 ml. Okay, so 1 centimeter cube is equal to 1 ml, right? Now with PCC, the same alcohol. So if this alcohol is treated with PCC, we get a carbonyl compound. So whenever we treat with PCC, either aldehydes will form or ketones will form. But the hint given is here is it answers to the silver mirror test. That means this one compound formed is your aldehyde, right? And if you remember, primary alcohols will give you aldehydes. Secondary alcohols will give you ketones. So that means this monohydric alcohol should be a primary aldehyde. Okay. Now primary alcohol. So now you can check the option. This is a secondary alcohol. We can eliminate this option. This is also a secondary alcohol. We can eliminate this one. So we are left with option number B and option number D. Okay. Now coming to this value, 112 ml is produced at STP. That means how many moles of produced? We know if we divide 112 ml by 22,400, that is STP, we will get 1 by 200 moles. The number of moles of CH4 will be 1 by 200. So now 1 mole of this compound has reacted with this one. So I can say that the number of moles of this one is 1 by 200, right? So now you can use number of moles formula, that is given mass by molar mass. So number of moles is 1 by 200 and the given mass for you is 0.44 and molar mass we have to find out. So if you solve this one, we will get the molar mass of the compound will be 88 grams. Okay. So now out of the two options that were left, B and D, just check the molecular mass of the compound. If the molecular mass comes out to be 88 gram, then that will be the answer. Okay. So for this one, if you treat here we have 3, 4, 5 carbons. So if you check the molar mass of this compound, it will be coming around 88 gram per mole. Okay. So the correct answer for this question will be option number B. So once again, listen this question, little tricky. First of all, a monohydric alcohol is given. That means only one OH group is present. Now this one is reacting with MEMGI. After reacting with this one, this CH4 is produced, which is 112 ml. And this compound on reacting with PCC is giving you aldehyde. How we came to know? Because it answers your silver mirror test, that is Tollens reagent. Right. Now we know that primary alcohols will give you aldehydes and secondary alcohols will give you ketones. So that means this monohydric alcohol must be a primary alcohol. From the options you can see this first option is a secondary alcohol and the third option is also secondary alcohol. So we can eliminate these two. Now coming to these two, if you have remembered 112 ml is produced, we can calculate how many moles are there, right? So given volume by molar volume, so that is 1 by 200 mole. Now, so I can say this monohydric alcohol moles are 1 by 200. Now, number of moles is equal to given mass by molar mass. So, the molar mass of this compound is 88 gram. So, now you have to check these two options, calculate their masses, and if you are getting 88 gram, then that will be the answer. So, correct answer for this question is option number B. If you have any doubt in this question, please comment. I'll be addressing it. So, little tricky question, but important one. Next. Okay. Phenol reacts with bromine in CS2 at low temperature to give. So if you have phenol and if you treat with bromine water will give you 2,4,6 all tribromo derivative will get, but if we take bromine in CS2, we get only ortho and para products, right? So separate products will get here. This is my ortho product and this is the para product. Okay, so the correct answer for this question will be ortho and para bromophenol. Okay, so correct answer will be number 2, or that is option number B. Okay, so that's where the top 30 questions of this chapter, alcohols, phenols and ethers. So please prepare all the reactions, all the name reactions you have, all the preparation methods of alcohols, and for ethers especially you have to prepare the Williamson ether synthesis and the reaction with HI. Okay, so if you have found this video helpful, please like, share and subscribe our channel. The links of other top 30 questions are also given in the description section, and the link of the WhatsApp channel is also there. Please join it for further updates.